All right, let's do another inverse where we are on a restricted domain. So what if I ask you to find the inverse of x squared plus 1 on x greater than or equal to 0? Okay, so again, this is our parabola shifted up 1 unit, but it's only half the parabola, guys. All right, because I'm saying, hey, I can only graph x coordinates that are greater than or equal to 0. This is something we do when we want to find the inverse of a function that on its entire domain may not be 1 to 1. And we know with the parabola we have a u which is not 1 to 1. So here I have made x squared plus 1 1 to 1 so I can actually find the inverse. All right, so let's go through finding the inverse. All right, I get rid of my function notation. All right, I switch my x and y. I try to solve for y. All right, so I'm here where I need to undo a square, so I use a square root. All right, and lastly, I write my inverse notation, and I have my inverse function, okay? Now, what's the domain of this inverse? Okay, well, let's go back to our original function, x squared plus 1. We've said the domain is x greater than or equal to 0. What would the range be? All right, well, we know it's the parabola shifted up 1. We only have half of it, so it looks to me like the range is y greater than or equal to 1. Okay, well, so down here for the inverse, what's going to be our domain? Well, our domain is going to be whatever the range was for our function. So our domain is x greater than or equal to 1. Notice how it's flipped from the range of the function. All right. Similarly, the range for the inverse is just going to be the domain of the original function, and so we get y greater than or equal to 0. Can we graph this inverse, the square root of x minus 1? I sure hope so. All right, one way to graph it is to flip it over the line y equals x. Another way to graph it is to say, hey, well, that's just the square root of x shifted to the right 1. Another way to graph it is to just use points. Note our y-intercept becomes our x-intercept. Okay?